Hi everyone, my name is Suram and I welcome you all to my YouTube channel. In today's video we are going to discuss the question answers of standard 8th chapter light energy. So all the question answers we are going to discuss in today's video. Light energy chapter 5, 8th standard. So let's see. First A part, fill in the blanks with the suitable words. So first Philip is the dash of a spherical mirror is called its pole, that is the geometric center. And second is the distance between pole and dash is known as the radius of curvature. Distance between pole and center of curvature. Then third is the principal focus of a concave mirror is a real point. It is the dash point, but for a convex mirror it is a dash point, that is the virtual point. Real and virtual point. A convex mirror cannot be a dash image of an object placed in front of it. A convex mirror cannot form a real image. Dash is the phenomena of bending of light when a light ray passes from one transparent medium to another. So here is the refraction is the phenomenon. Next, number 6, when a light ray travels obliquely from dash medium to a dash medium, it bends towards the normal, that is rare to denser. Then water is optically denser than dash but optically rarer as compared to dash. Water is optically denser than air, but optically rarer than glass. Number 8, when the light passes through a prism, it gets split up into 7 colors. Here 7 Philips. Number 7, it is air and glass. 8th, when light passes through a prism, it gets split up to 7 colors. So these are the Philips. Give one word for the following. Number 1, bending of path of a ray of light incident obliquely at the surface separating two transparent media, that is called the refraction. Splitting of white light into a band of 7 colors after refraction through a prism, that is called the dispersion. Then mirrors with the curved surfaces are called the spherical mirrors. Then mirror whose inner surface is silvered and reflection take place from the outer surface, that is called the convex mirror. The geometric center of a spherical mirror, that is called the pole. Distance from the pole to the principal focus of a spherical mirror, that is called the focal length. The center of the sphere of which a given mirror is a part, that is called the center of curvature. Then the band of 7 colors formed on a screen due to the splitting of white light on passing through a prism, that is called the spectrum. So these are the give one word. Next we have define these terms. The very first is the refractive index. Refractive index, it is the ratio of the speed of light in air or vacuum to the speed of light in the given medium. So refraction of light. Second is the refraction of light. Bending of light when light passes obliquely from one transparent medium to another transparent medium. Number 3, principal focus of a concave mirror, the point on the principal axis where a light beam traveling parallel to the principal axis of a spherical mirror after reflection meets. Then we have principal axis. Principal axis is a line passing through a pole and the center of curvature is called the principal axis. Then we have radius of curvature. Radius of curvature is the distance between the pole and the center of curvature, is called the radius of curvature. Then dispersion of light, splitting of white light into its constituent 7 colors on passing through a dispersive medium like prism. Then next we have differentiate between the following. So very first is the difference between concave mirror and the convex mirror. So concave mirror, if the outer surface of the mirror is polished and the inner surface behave as a reflecting surface, it is called the concave mirror. Convex mirror, if the inner surface of the mirror is polished and the outer surface behave as a reflecting surface, it is called the convex mirror. Concave mirror, it forms real and virtual images, but convex mirror, it always forms the virtual image. Then next we have The real image and the virtual image. The real image is an image that when formed when light rays it is formed when the light rays from one object after reflection actually meet at one point. That is called the real image. Virtual image is formed when the light rays from an object after reflection appears to meet at one point. Then second, we have the real image can be obtained on a screen, and virtual image cannot be obtained on the screen. The real image is inverted image and virtual image is an erect image. The next we have reflection of light and the refraction of light. Reflection of light, it is the phenomenon of returning back of light into the same medium after striking a smooth surface. That is called the reflection of light. Then refraction of light, then the phenomenon of bending of light at the interface of two media when light passes from one medium to another medium is called the refraction of light. Then we have the diminished image and the enlarged image. So diminished image, an image is smaller than the object, enlarged image is larger than the object. So diminished image we are able to see in the diminished image in the object in the convex mirror. So we are able to see the enlarged image of an object in the case of concave mirror. So these are the differentiate. Then we have the answer these questions. So very first is, what is a spherical mirror? What are two its kinds? Spherical mirrors, a slice taken out from a hollow glass sphere and silver from one side so that the reflection takes place on the other side. So it is of two kinds, concave mirror and the convex mirror. Then explain the following terms related to the spherical mirror. First is pole. The geometric center of the spherical mirror is called the pole. Then we have center of curvature. Center of curvature is the imaginary sphere, is the center of that imaginary sphere to which the mirror is a part. Then we have the radius of curvature. Radius of curvature is the radius of that imaginary sphere to which the mirror is a part. Then principal axis is an imaginary line passing through pole and the center of curvature is called the principal axis of the mirror. The next we have state any two rules for drawing the geometric images for an object placed in front of the concave mirror. A ray traveling parallel to the principal axis of a concave mirror passes through the principal focus after reflection. That is the first rule. Second, we have a ray passing through the principal focus of a concave mirror gets reflected parallel to the principal axis. Fifth, where should an object be placed in front of the concave mirror as well as to obtain its inverted and the diminished image and inverted and the enlarged image. So A part, it should be placed beyond C, and the B part, inverted and enlarged image, it should be between C and F, between center of curvature and focus. Next we have given two uses of concave mirrors. They are used as the reflectors in torches, headlights of vehicles and in projectors. Concave mirrors are used in solar cookers and the solar furnaces so as to focus the sun radiation at a place. Then we have the state 1 use of a convex mirror. It is used as a rear view mirror in the vehicles so as to it forms the erect and diminished image and give a wider view of approaching the vehicles. What is the refraction of light? The phenomenon of bending of light at the interface of the two media when light passes from one medium to another. That is called the refraction of light. Then we have what do you mean by the following terms: incident ray, refracted ray, and angle of incidence and angle of refraction. Incident ray, the ray traveling in first medium and falling at the surface separating the two media, is called the incident ray. Then we have the refracted ray, the ray traveling in second medium after undergoing the refraction is called the refracted ray. Angle of incidence, the angle between the incident ray and the normal ray, is called the angle of incidence. Angle of refraction, the angle between the refracted ray and the normal ray, is called the angle of refraction. Then we have in which direction does the light ray bend when it passes obliquely from a rare medium to denser medium and from denser to the rare medium. From rare to denser it will bend towards the normal, and from denser to rare it will bend away from the normal. State the two laws of refraction. The incident ray, the refracted ray, and the normal at the point of incidence all lies in the same plane. Very first. Second, we have the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant, and the constant is called the refractive index. So this law is also known as the Snell's law. Then we have what do you mean by the optically denser and the optically rarer medium. So medium in which the light travels faster is called the rarer medium, and the medium in which the light travels slower is called the denser medium. Which is optically denser, air or water? Give reason 2. Water is more optically denser than air because speed of light is less in water than in air. Is water optically denser to air or glass? Yes, water is optically denser to air, and water is not optically denser to glass. Define refractive index of a medium. What is its unit? Refractive index is the ratio of speed of light in air or vacuum to the speed of light in the given medium. So it is the ratio of speed of light in air to the speed of light in the given medium. It has no unit because it is the ratio of the two similar quantities. What is atmospheric refraction? Atmospheric refraction is the refraction of light in the atmosphere due to the changing density of the air is called the atmospheric refraction. What is the prism? Draw a diagram to show the refraction through a prism. So prism is a transparent material bounded by the two planes of rectangular refracting surfaces inclined at an angle, which is called the angle of prism. So this is the diagram. Here we can show the refraction through the prism. So this we have discussed already in the chapter. So this is how you have to draw this diagram. So what do you mean by the dispersion of light? The phenomenon of splitting of white light into its constituent color, that is called the dispersion of light. So these are about the question answers. Next we have state whether the following statements are true or false. If false, then we have to rewrite the correct form of the statements. So very first statement is, in a convex mirror, reflection takes place on the outer surface. That is true. Second, a ray of light passing through the center of curvature of a concave mirror is reflected back along the same path. That is true. Third, image formed by a concave mirror is always real. That is false. It can form real and virtual both. It can be real or virtual both. The distance between pole and focus of a spherical mirror is called the radius of curvature. No, that is false. It is called the focal length. A convex mirror is fitted in vehicles to enable the drivers to view the traffic coming from behind. That is true. A convex mirror is used as a reflector in the solar cooker. That is false. It is a concave mirror that is used. Next we have a ray of light on passing through from glass to air bent towards the normal. That is false. It bends away from the normal. It bends away from the normal. Next we have a ray of light incident normally on air-water interface goes straight without any bending. True. Glass is optically denser than water. That is true. Number 10. Real depth of a tank filled with water is greater than its apparent depth. That is true. A ray of light passing through the focus of a mirror goes straight even after the reflection from a mirror. That is true. 12th, for refraction through a glass slab, angle of emergence is equal to the angle of incidence. That is true again. 13, when white light is dispersed from a prism, the deviation of red color is more than the deviation of the violet color. That is false. Deviation of violet color is more than the deviation of red color. Number 14, a lemon kept in the water contained in a glass tumbler appears to be of bigger size when viewed from the sides. That is true. Then we have the G part. Encircle the odd one out. Give reasons for your choice. So very first, the parts are incident ray, refracted ray, angle of incidence, angle of refraction, dispersion of light. Then dispersion of light is different. This is the odd one because all other are the terms used in the refraction, while the dispersion of light is the phenomenon of refraction of light. Then second we have car headlight mirror, makeup mirror, rear view mirror, and dentist mirror. So here the rear view mirror is the odd one. That is, other are the uses of concave mirror, and rear view mirror is the uses of convex mirror. The next third we have pole center of curvatures, principal focus, principal axis, and refractive index. The refractive index is different because the refractive index is the degree of measure of refraction from the different media, while other are the terms used in the case of spherical mirrors. So this is the G part. Next we have the give reasons for the following. So very first is light bend towards the normal when it travels obliquely from air to glass. This is the reason that glass is much denser than air. Speed of light is more in air and than in glass, so therefore light bends towards the normal. A pencil partly immersed at the bottom of a tumbler appears to be raised when water is poured into the tumbler. So that is because the lower surface of the tumbler full of water seems to be raised due to the refraction of light. So pencil appears to be at apparent depth rather than the real depth of the tumbler. Then a coin is placed at the bottom of the tumbler, appears to be raised when water is poured into the tumbler. That is again lower surface appears to be at the apparent depth due to the refraction of light. The sun is visible for 2 minutes even before sunrise or even after sunset. That is due to the refraction of light from the different layers of air present in the atmosphere. So sun appears to be apparent position due to the refraction, so it takes 2 minutes before sunrise or after sunset. Principal focus is the real point for the concave mirror but virtual point for the convex mirror. That is because it is due to the reason that a ray of light after reflection from the mirror actually meet at focus in case of concave mirror, or it appears to diverge from the focus in case of convex mirror. Then we have concave mirror is used as a reflector in car headlights. So if the bulb is placed at the focus of the concave mirror, the beam of light will be parallel to the axis of the bulb. So as to obtain the parallel beam of light, concave mirror is used in the car headlights. So convex mirror is used as a rear view mirror in the vehicles because the convex mirror is forming the virtual and diminished image when the object is placed at any position in front of the mirror, so it covers a larger area behind the vehicles. The virtual image cannot be obtained on the screen because virtual image is formed by when the rays are produced to meet at one point. So the virtual image cannot be formed on the screen. Then we have the matching. Match the position of an object and the characteristics of the image formed by the concave mirror. Then when the object is at C, real inverted of the same size image at C. At infinity, a real inverted and point size image at F. At F, when the object is at focus, real inverted and highly enlarged images at infinity. So when object is between center of curvature and infinity, real inverted and diminished image formed between focus and center of curvature. And between F and C, between focus and center of curvature, real inverted and enlarged image formed beyond center of curvature. Between pole and focus, virtual erect and enlarged image formed behind the mirror. So these are the matching. Then we have the multiple choice questions. Very first, if the angle of incidence is 30, then what is the angle of refraction? That is 30. And a spherical mirror whose inner surface is reflecting surface, that is called the concave mirror. And if a ray of light falling on the mirror is called the incident ray. For an image to be formed at the center of curvature of a concave mirror, the object must be placed in front of the mirror at a same point, that is center of curvature. The bending of light when it travels from one transparent medium to another is called the refraction. And the speed of light in maximum in vacuum. The speed of light is maximum in vacuum. And then next we have the when white light passes through a prism, which color is deviated the least? So that is the red. The angle between the normal and the refracted ray is called it is called the angle of refraction. So focal length f for the spherical mirror is related to the radius of curvature r as per the relation f is equal to r by 2. Focal length is equal to half of the radius of curvature. So these are the multiple choice questions. Then we have next diagram based questions. So here you have to draw the diagrams. Draw ray diagrams to show the image formed by a concave mirror when a linear object is placed beyond the center of curvature. So very first is the beyond center of curvature. When the object is beyond center of curvature, the image will be like this. Ray diagram will be like this. One ray parallel to principal axis will pass through focus, and one ray passing through the center of curvature will pass straight. So where these two lines intersect, here the image will form. Then next B part we have at the center of curvature. When the image object is at the center of curvature, then at the center of curvature image will also be at the center of curvature. Parallel to principal axis will pass through focus, and passing from focus will become parallel to principal axis. So here the image will form. Then next we have between the center of curvature and the focus. Between the center of curvature and the focus, when the object is between C and F, here is the object So one ray parallel to principal axis will pass through focus, and one ray passing from the center of curvature will go straight. So where these rays intersect, here the image will formed. Is it? The next second part, show the paths of the refractor ray in both the cases. That is given on your book. So first A part, the diagram will be like this. The ray parallel to principal axis will pass through focus. Second B part, a ray which is parallel to principal axis will appear to be diverged from focus in case of convex mirror. Then we have see the adjacent figure and answer the following questions. So based on this diagram, we have to answer the questions. So first question is, which phenomenon is refractor is being represented by the diagram? Will you find it? Which is the phenomena here? That is the refraction of light. So refraction of light, what is the raffination? The phenomena of bending of light at the interface of the two medium, and the light passes from one medium to another medium. Then second we have mark incident ray, normal ray and the refracted ray. Incident ray here is, that is OI or IO. Then normal ray is ON and refracted ray is OR. ON is the, or N dash is the normal ray, ON we can say, or N dash is the normal ray, and OR is the refracted ray. Then angle of incidence, what are the values of angle of incidence and the angle of refraction? Angle of incidence is 45, here this is the angle of incidence, and angle of refraction is 30. Then we have out of media A and B, which media is optically denser and which is optically rarer? Give reason. Which is optically denser, A or B? Optically denser is B, because light is bending towards the normal here. Is it? Light is going from rare to denser, so it will bend towards the normal. So this one, A1 medium is the rare medium and B is the denser medium. Medium is optically rarer than the medium B because refractor ray is bending towards the normal. Is it? So then we have the next number 4. Draw a neat diagram, show refraction of light, showing the reflection of light through a prism. Mark incident ray, refractor ray, emergent ray, angle of prism and the angle of deviation. So simply we have to draw the refraction of light from a prism. The same diagram that we have drawn already. So all these points we have to mark here. That is incident ray. Incident ray here is PE. This ray is called the incident ray. So you have to write this ray is the incident ray, PE. Then we have the refractor ray. Refractor ray is here, EF. This ray is the refractor ray. Then we have emergent ray. Emergent ray is FS. This you have to write in the same way, FS. Then angle of prism. Angle of prism is this angle. A is the angle of prism. Then we have angle of deviation.